Okay, so 3 notes, parallel and perpendicular lines. These are actually very, very simple notes as long as we don't try to overthink things, okay? What I really want you to do right now is I want you to discuss with your partners what you think the difference are between parallel and perpendicular lines. I'm going to give you about 20, 30 seconds. Ready, set, go. Hey, Blake, can you grab my door for me? Can you shut my door for me? Thank you, bud. No, I have to record myself. Okay, 3 notes, parallel and perpendicular lines. Again, these are going to be very, very simple notes as long as you don't overthink it. You've kind of discussed with your partners what parallel and perpendicular lines are, and you have a basic understanding. Parallel lines, y'all could probably explain this to me very quickly just by the show of your arms. What do parallel lines look like? Good job. They're lines that never what? Good. So above the word parallel or below it, will you write never touch? Now, perpendicular lines, they're very, very specific. They do intersect, and they intersect at a specific point. That means they touch at a what? Good, 90-degree angle, okay? They're going to create a right angle when they touch. And then anything else, if it's touching, that's just an intersecting line. So that's just going to be a case of neithers here. So let's look at these 3 examples. This first example, we've got 2 lines. They are touching right here. They're touching one time, which is awesome. But if they're touching, that means they're definitely not parallel. And then we've got to ask ourselves, are they touching at a 90-degree angle? The only way we would know that is if it indicated it, and it didn't show any indication. So therefore, if this is not a perpendicular, this has to be a neither situation. Looking at the next lines, we notice that they're touching, and they're touching at a very specific point. It's so specific that they indicated it with a 90-degree angle. Since they're touching, they're definitely not parallel. And since it's a specific point, 90-degree angle, these are considered perpendicular lines. They create a right angle. Now these last ones, these are going to be parallel because they never touch. You're going to notice that these lines actually create the L's just like in parallel. They're never going to touch. They're going to run side by side, and that's all they're going to do. So our 2 specific situations today are parallel, perpendicular. And if you'll look at these examples indicate that these first 2 lines, if you put them in your calculator, are going to be parallel lines. So I don't think I have my calculator pulled up. Let's go look. Well, guys, this is no good. My calculator will not pull up on my screen. So, oh, there it goes. Now that I'm talking bad about it, all of a sudden it wants to show up. We're going to type these into our y equals screen because both of these equations are in y equals format. So, well, now it's frozen. We're going to hope it shows up sooner or later. We're just going to keep moving. Okay, so parallel lines are going to be examples like so, y equals. We're going to type in 2x minus 4 and 8 plus 2x. So 2x minus 4, 8 plus 2x. They've told us these are parallel lines, but we're going to go check. Looks like they are. They're running side by side, never touching. So what this means is these parallel lines are going to have the same slopes. Oh, wow. You don't need to write that twice. Same slopes. So if you go look, y equals mx plus b format, my slope in this first line is 2. And again, this is y equals mx plus b format, but they kind of just trying to confuse you. Make sure your m goes in front of your x always. So both of these two lines have slopes of 2. Therefore, they're the same, and that means they are going to be parallel. Perpendicular lines are kind of cool. They're a little bit different. These are words you are going to have heard before, but they're just different. You might not understand them. So perpendicular lines are going to have opposite reciprocal slopes. And reciprocal just means that it's been flipped, okay? So if you'll just write the word flip, I have a feeling you'll understand it more. But let's go check out what this means. So what I'm going to do is I'm going to write y equals mx plus b underneath my equation, both of them. And we're going to identify our slopes so that we can see what changes. So in line 1, my slope was 3. Right here. Line 2, my slope is negative 1/3. And we've been told that these are perpendicular lines, so I'm going to go check. We're going to type in 3x plus 1. And then my next equation is negative 1/3 x plus 1. So negative 1/3 x plus 1. When I graph them, they're going to cross each other at a specific point and specifically a right angle. The way we're going to prove that is by looking to see if they're opposite reciprocals. Opposite means that they have different signs, okay? So that means one of them has to be positive, one of them has to be negative. Doesn't matter which is which, okay? Just one has to be positive, one has to be negative. So line 1 was my positive line, and line 2 was my negative line. So we've got that checked off. Opposite means sign is my opposite. So we've got a positive here, a negative here. And then reciprocal means that they have to be flipped. So if I was putting this as a rise over run, my first slope would be 3/1. But if I were to flip that, it should create my second slope. And it does because 3/1 will become 1/3. Since one was positive, one was negative, one was 3/1, one was 1/3, they are now perpendicular lines because they are opposite reciprocal slopes. So let's go look at some of these examples and see if this makes any more sense, okay? First example says line T and line U. The nice thing about these two examples is they already gave us the slopes. We just have to figure out if they're the same, opposite, or neither. So if you would, above the word parallel, I'd like for you to write in the word same. And above perpendicular, write opposite, flip. Oppo, flip. Okay? So now let's go back and look at line T's slope. It's 3. So this is going to be a positive slope. And then if we look at our next line, we've got a negative slope. So they're definitely not the same. I can get rid of parallel. But one is positive, one is negative, so that means they are opposites. But now I have to see if they're flipped. So the first slope is 3/1. The second slope is 3/1. That has not been flipped. So since it's not opposite and flipped, it can't be perpendicular. The only other option is neither. Line V, line W, let's go compare those, okay? One is negative, one is positive. So that means I've got oppo, flip here, just as a reminder. Opposite is good to go. It can't be parallel because it's not the same. Now let's go see if they're flipped, which means I've got to take one, flip it, to see if it creates the other. So 1/2 should become 2/1, which would simplify to be 2. So that is opposite. It's also flipped. Therefore, these two lines would be perpendicular. Let's look at the next line. We've got m equals 6/4 and m equals 3/2. So the first thing I'm going to go write is parallel has to be same. Perpendicular has to be oppo flips. Okay, one is positive. The second one's positive, so they're definitely not opposite, therefore they can't be perpendicular. So now I got to go see if they're the same. And by appearance, they don't look the same. One has 6/4, one has 3/2. But guys, if I were to simplify 6/4, that simplifies to be 3/2, meaning parallel because they're the exact same slopes. Now let's look at these next examples. Instead of giving us the slopes, they actually gave us the equation this time. So I'm going to have to go identify the slopes. And the way that I'm going to do that is I am going to look for my m. This is y equals by itself, so I know it's y equals mx plus b format. My slope for this first line is 2. Again, y is by itself, so y equals mx plus b format. My slope for the second line is -1/2. In order for them to be parallel, they have to be the same. In order for them to be perpendicular, they have to be opposite flippers. And then neither just means doesn't fit the category of either. So one is positive, one is negative. That means they're definitely opposite, so they can't be parallel. If I were to put this as 2/1 and be able to flip it, it would flip into 1/2, and that is what is flipped on the second line. So since they are flipped, they're also opposite. These lines would be perpendicular. Let's go look at our next line. This is not y by itself, but it still does have y on one side, meaning it's point slope format, which would be y minus y1 equals m parentheses x minus x1. And this is really easy to identify slope because it's still right out in front of your x. Your slope is 3. This next line's pretty easy because it's y equals mx plus b format. That's nice, simple. That means my slope is 3. If they're parallel, they have to have the same slope. If they're perpendicular, they have to have the opposite flip. Neither just means neither of those work. So if I go look at these two, one's positive, the second one's positive, so they're definitely not opposites, so they can't be perpendicular. The first one's 3, the second one's 3, they're the exact same slope, therefore they're parallel. One more example, we've got y by itself, so y equals mx. They tried to switch it on you, so make sure you put your m in front of your x. That means my slope for this first line is -2. And this is standard form down here, so it's ax plus by equals c. All I have to do is remember that slope is -a/b, or opposite of a over b, meaning I've got the opposite of 2 to be -2, and my b is +3. So my slope here is -2/3. In order for them to be parallel, they have to be the exact same. In order for them to be perpendicular, they'd have to be opposite flip. Neither just means it could be either. So looking at my two slopes, one is negative, the second one is negative, so they're definitely not the same. They can't be parallel. Oh, wow, that's way wrong. They're definitely not opposite, so they can't be perpendicular. They're both negatives. Now, on this top one, 2/1 is not the exact same as 2/3. So since they're not the exact same number, they can't be parallel. The only option here is neither. This last part of your notes matches the bottom part of your practice. So what we're going to do is we're going to go find the slope in each of these problems. We've got y minus y1 equals m parentheses x minus x1. Find your slope is pretty easy. My slope for this first problem is 2/3. And I'm going to say m equals just so we can continually see that. My y is by itself in this second problem, so that means it's y equals mx plus b. They just tried to switch up where the m and the b are. So make sure you pay attention. It's the number in front of your x. Your slope is -5/7. Your third example is y by itself. So again, that's y equals mx plus b format. They did it nice this time. My slope was easy to find. It's -7. This last one is standard form. They're trying to trick you, make you all confused. All you have to do is remember that your slope is the opposite of a over b. And you have to be smart enough to recognize that the understood number in front of your x is 1. The understood number in front of your y is 1. So the opposite of 1 is -1. And the b is 1. That would simplify to be -1 here. Parallel slopes means they have to be the exact same. So this column should be very, very simple. You're just going to write the exact same slope for every single problem. You don't change it at all because you've got to keep them parallel. The perpendicular slope is trying to be tricky. Remember, it's the opposite sign and it's flipped. So my original problem is positive. That means my new sign is going to be negative. And 2/3 flipped is going to become 3/2 to be a perpendicular slope. So notice it originally was a positive 2/3. In order to become perpendicular, we've got to make it negative and flip my fraction. In my original problem for the second example, it's negative, so my new slope is going to be positive. And instead of 5/7, we're going to flip it to be 7/5. My third example was negative, so my new slope is going to be positive. This, if I had rise over run, I can put 7/1. In order to flip that, I'm going to become 1/7. The reason I can put it as -7/1, anything over 1 is itself, so that just allows you to see it as a fraction. My last one, we've got -1/1. That means I've got to have a new positive slope. 1/1 flip just stays as 1/1, which simplifies to be